Welcome back after your lunch. So, today the industry panel is supposed to be in person, but due to some of them facing physical and personal issues, right, they couldn't come, but certainly we still welcome them to join us online. So, let me just quickly introduce the panelists, and then from there, I will invite each of them to give a brief overview of their representations for the standards that they represent for, and also their role in driving the standards. So on the left-hand side of mine and to your right-hand side, you see Gillian Makamara, who's a project officer at ITU. And then to her right or to my left, you see Professor Lee Heng-sung from Jeju University of Korea. And, he just waved hi to you guys. And then you have Professor Zhang Qiang from USTC, and you have Hao Qing here, Dr. Hao Qing from National University of Singapore, but also representing the National Quantum Safe Network, and myself from NUS as well. All right. So maybe let me start with Gillian. Can you hear me? Okay, very good. So why don't you spend a few minutes introducing yourself and talk about the standards that you represent and your role in driving the standards for quantum cryptography. Thank you. Yeah, thank you for the explanation. So I'll move on now to Professor Zhang Qiang to share more about his role.
Hi, I'm the local organizer, and then in the academic side, I'm doing the fiber QKD, like the MDI QKD, twin field QKD, and for the industrial side, I'm on the board of two companies. One is for the quantum communication, the CES quantum network. You may see it outside, and also the quantum atmosphere LiDAR company. So basically for quantum measurement. And for the standardization, I'm involved in the ITU-T and also the JTC3. I'm from the international side. I'm the ITU-T focus group for quantum information, quantum technology for network. I'm the chairman for that one. And also I'm representing China. I'm the head of the delegation of China delegation to attend the JTC3 for the past three JTC3 conferences. So I worked with Gillian and also with Hysun a lot. And inside of China, we have a national TC, technology committee called the Quantum Computation and the Measurement Committee. I'm the Jian Weipan is the chief the chairman for that TC, and I'm the secretary in general for that TC. And then actually in China, we have we actually put a quantum cryptography in the communication side. It's a kind of sub TC in big TC, the communication TC. But the computation and the metrology, we put it together. So that's the basic things happen here. And of course, I'm also involved of the work of the TC for quantum cryptography. Yeah, that's it.
Thank you. So over to you, Hao Qing.
Hello. Thank you. Thanks for the introduction. My name is Hao from US. So I have been working on the standardization work on QKD for a while, mainly involved in ITU-T, ISO IEC JTC1, and ETSI ISG QKD. This is an international participation. So in Singapore, I also serve as a co-chair for the Quantum Communication Network Task Force to set up the local standard. So I also serve as ITU-T Joint Coordination Activity QKD Network Vice Chair, as well as Associate Rapporteur for the question 15, which is on the topic of quantum security in SG17. I contribute to several quantum or quantum key distribution network work item or standard drafting among the ITU-T, ISO, and the ETSI. I look forward for the discussion. Thank you.
Wow, so thank you to everyone for sharing your roles and responsibilities across the different standards and certification bodies. So let's be a little bit more deliberate in our discussion moving forward. So the key topic of this conference, I think we can all agree it will be related to quantum key distribution, right? So maybe each of you, right? Again, starting from Jillian, can you explain more, in terms of ITU expectations? What can we see from ITU work? What kind of certification, what kind of programs or recommendation can we expect, from the perspective of the community? Not only giving us, running us down with the deliverables, but also the timelines, right? If you could. So just share a little bit of those expectations.
Yes, so I'm going to maybe interrupt your planning here. And I think it's good we hear from the community, right? And the community is actually sitting on stage. So I'm going to throw it back to Hao and Chan to give us a bit more detail on that. And I can supplement if that's okay.
Yeah, sure. So maybe Hao Qing, we can turn the arrow to you.
For the ITUT or?
So you can, speak on the behalf of ITU as well.
Okay. Yeah. So I think the premise I would like to share is on the overall activity in ITUT. That's including different aspects on the standardization, on the protocol aspect in SG11, on the network aspect, architecture on SG13, and also the security aspect in SG17. So a few years ago back, there's also the focus group on the quantum information technology for the network established, also co-chaired by Professor Zheng Qiang. So these are the overall activity, and a different study group address the different perspective. Because we don't yet have a dedicated study group on the quantum or QKD itself. So all these work item or activity are spread into different study group. On top of that, there's also one more coordination group called Joint Coordination Activity Group on the QKD network. So this JCA QKDN is aiming for the coordination, collaboration, and also for the harmonization of different standard on the QKD among different study group inside ITUT and also outside ITUT between SDO such as ISO, ETSI, and also other organizations. So this is a briefly overview on activity on the QKD related standard overview. Thank you.
Thank you. So maybe over to you, Professor Lee. So I understand that you are now the chair of a new committee, right, between IEC and ISO. So what can we expect in terms of standards and certifications regarding QKD from your committee?
Let me briefly introduce that JTC3 activities. Actually, the standardization of quantum technology, sometimes we just confuse the quantum information technology. Clearly, we do not have any kind of currently the clear definition between two terms, quantum information and quantum technologies. But I recognize that the kind of three groups is initiated, the quantum standardization of a whole field of quantum technology. Then the first group is ITU. It's based on the QKD. It's really the kind of very well developed for a kind of commercialization and even industrialization among all the quantum technologies. And also the other movement is starting from the 2018 JTC1 of ISO IEC, especially Working Group 14. That is also standardization on the quantum information technology. So probably they also a little bit dealing with quantum QKD. Then it means that our JTC3 is a kind of so not the front runner. So when you just create that the JTC3, then probably we just recognize that the initiatives by ITU and also some of our works developed in JTC1 Working Group 14. So currently we do not focus on much about the QKD issues, but actually the later QKD issues will be handled by some of our currently at that group, quantum communication. So if you don't mind, I would like to just show that the current structure of JTC3. Now we have 3 plenary meetings, first Seoul and Edinburgh last year, and this May, we just finished that third plenary meeting, and also fourth one will be in Denmark in November. So can I share that some information for you for something like a current status of JTC3? I would like to share that
Yeah, I think you can try and share screen and see if it works.
Yes, yeah. Okay, I told you that is we just finished at the third plenary meeting in May.
Professor
Tokyo,
Lee,
this year, yes.
Professor Lee, yeah, hold on a minute. We're trying to broadcast your. Yes, it's not good. Yeah, I think you can continue.
It's okay.
Yeah, it's good.
Yeah. Okay. During the previous 1 year, we just created some ad hoc groups for evaluate some standardization activity works. We create mainly 6 ad hoc groups. Actually, it's don't just focus on the number. The first ad hoc group is the quantum sensors, and the next one is a quantum communication, and also quantum computing and simulation, the quantum random generator, and quantum enabling technology. And also another very fundamental ad hoc groups is terminology and also the basic meteorology. That is just before the Tokyo meeting. Then after that, now we just created the real working group on a specific technology. Still, the quantum communication is under the ad hoc group structure. There is a discussion that what kind of working group we can create from the element technology of quantum communications. And the other one is quantum enabling technology. So still we are just define that kind of what is the scope of quantum enabling technologies. Maybe this is also a part of that QKD issues. And ad hoc group 5 is probably most important key element part is quantum computing and simulation. Then currently, that the real working group is already approved, is in the field of terminology and quantities. Then the next working group 10 is quantum sensors, and working group 11 is a quantum computing supply chain, and working group 12 is quantum computing benchmark, and the working group 13 is a quantum random number generators. It's led by the Dr. Minghan Lee, is in China. So probably, I guess that he just attended this conference, so you get some kind of detailed information directed from him. Then these are what we are just considered. About the QKD, is maybe that is belonging to the quantum communication part. Then we just recognize that some the existing activities, mainly done by ITU, then probably we'll just pursue some kind of a different area. Maybe what is the Joint Technical Committee means under the IEC and ISO. It means that we try to some of our technologies are really involved between the hardware and software. So this is quantum technology. It's a really very good example case. In case also like information technology, then our standardization society is already acknowledged that this importance between some combination of hardware and software. So in 1987, that is created that the JTC1 led to standardization of information technology. In case of QKD, it's a kind of a very good exemplary case. We have to consider two parts. One is the hardware, the other one is the software. So probably if Edward Group 4 developed that quantum, that the QKD under the quantum communication, maybe some kind of software part is already discussed on the ITU. Maybe we'll just find out some kind of standardization area for some kind of hardware. So probably this is the way we have to find out some kind of a synergic effect among the parties, the SDOs. Okay.
Thank you.
That is my opinion.
Yeah, for sharing this list. So it looks like there's a lot of work, for the community to work on. So maybe to move on to Professor Zhang Qiang. What kind of challenges do you face, right, when you work on this kind of working groups? Is there like a lack of talent, getting people, like the students or the researchers, the professors to work on this kind of topics? Has that always been a challenge? Because, you clearly, has been leading a major program in research, right? And now you're coordinating standards for, the Chinese community. So are you doing this because it's part of your KPI, or it's just basically your interest in driving the technology, right? So this is a question that I asked myself as well, right, when I started working on the ISO standards for QKD.
Yeah, thank you for asking. First of all, I would like to tell that today we are, it's a little bit not very lucky we don't have the people to represent the ETSI, because ETSI is the first SDO to working on the QKD things, quantum cryptography. And then for the challenge now, because I'm doing all the kind of quantum technology standardization, but because today's conference is about cryptography, so I'll talk about the QKD things. I think the QKD problem is if you do for example, if you the two-phase, there are two problems basically to do the standardization for or how can I say, to make it to like the people to use it. I would like to say that. Why I work on the standardization? Because at first I believe that only with the standardization, people will use it. So I work on that. But later on, I found even you get some, we did some good jobs by ETSI, by ITU. One week ago, there is a national conference of China, inside of China, for the quantum cryptography. And then you can see many kind of group, many slides from the academic, from the company. And they mentioned, okay, they follow the ITU-T, the standardization, what is standardization. So that's a good thing, that's the achievement. But the very difficult thing is, if you want to sell the product to the bank, to the industry, to the, if it's for the commercial application, it's okay. As long as there is a kind of standardization, international standardization works. But they will ask, who can you verify that? We do not have a verify kind of place to verify whether the company is past the standardization or not. There is no verification place. That's the first thing. So now the National Lab of the China Quantum National Lab is establishing a quantum central infrastructure. One of the main purpose for that one is to do the verification, certification. That's number one. And number two, if you really want to the government or some, for example, very secure, some department, they require the security only for the internationalization is not enough. You basically need to go through the approval. You need to get the approval of the NSA, the National Security Agency. I mean, China, of course, not the United States, but I think for any country, if you want the government to use it, basically you need to go through the NSA. That one is kind of tough because in general, for the NSA, they are very, good side is they very, very strict. So you need to have a full kind of central infrastructure, not only the technology, not only the product maturity, but also how could you certify that? The standardization is the first step, but you need a certification, you need a kind of whole things, and then you can get approval for the National Security Agency, then probably you get a chance to widely use it. So that's the basic thing, and also why I'm working on that. And sometimes I would like to see it's good, but sometimes it's kind of frustrated, not like research. Research like only depends on what you have done in your lab.
Yep. Yeah, thank you very much for sharing those insights, and I can concur to that. Having run businesses in the U.S., for relatively big banks in the past, right? I would say that what Professor Zhang Jiang has articulated earlier is certainly very real, right? When you want to put certain things into production, you get your regulators, you get your controls officers coming to you asking, is this particular device certified? And then, it becomes a very open-ended question, because then how do you certify a quantum device? And, nobody has the answer, not even the regulators today. And when you go to the manufacturer, they themselves, they're also struggling in answering these kind of questions. But I'll say that in recent months, right, there is an ongoing discussion, kind of like piggybacking on geopolitical tensions as well, is that besides certification standards, even if we get that done, can we address the supply chain question? So I give you a very hypothetical scenario, right? So imagine a US entity, they want to deploy QKD. And again, assuming that you have standards already in place, there are accredited labs that you can use where you can send the devices for certification. You get your certification, kind of like stamped by the authority, right? The local authority. But then, your stakeholders, for instance, your CISOs or your CTO or your product line managers, they're going to ask you, right, where is this device made? Is it made in the US or is it made in Europe, in Asia? And if it's in Asia, which country, right? So then you may say that there are certain countries that are not compatible with, your host, entity. And then, things get a little bit more complicated, and that's where export control comes in. So to that end, maybe to Gillian, sorry. So Gillian, has export control been a topic that you guys talk about at ITU?
It has, but we have not really talked about it in the actual technical work for standardization. So we have open workshops where we raise issues around different aspects of the technologies, right? And export controls is one of the biggest problems that's out there. It's something that we are trying to discuss, because at this moment, that's all we can do, discuss, but we do see it creeping in even in the technical work in terms of how one contributor from country X, just to keep it neutral, will approach something versus a contributor from country Y. We see some of the government and policy agendas creeping in, which is always fair. However, the challenge is now getting that balance. When do we incorporate all these different views and perspectives, and how do we try to separate that from the actual technical needs? So that's one of the challenges that we actually have in the ITU, because we have a wide group of people participating from different places worldwide. And there's no easy answer on how to solve the issue with export controls, but one of the things that we can keep doing is ensure that we keep the standardization process as transparent and open, ensure that we keep the spirit of consensus in the process. That's the best answer I can give you for now, because this is really, we can talk about this for days. We can go round and round, and we won't have an easy answer for this. But I think from a simple perspective, we should just keep the spirit of standard building in everything that we do. I also wanted to add a point to Chang's mentioned before when it comes to other standardization challenges. I think when we're developing any field, research is really important, right? But we also look at the practical deployments. Some academics feel that standards is where research goes to die. I've heard this from quite a few people. And this is also one of the perspectives that we have to challenge. Again, knowing when to standardize is one of the biggest challenges, and we do have a framework for doing that, but it's not easy as the export controls discussion. So I just wanted to add that as well. Thank you.
Yeah, thanks, Julian. So I would like to add on to what she just said, right? Especially to the floor. So for most of you in academia, of course, working on upstream research is your main goal. But, we all hope to see this field develop into something that, the world would use, right? And as such, I think we need to take some accountability and, pay a bit more attention, paying it forward, in helping, some of these folks who are running the workshops or working groups to, contribute your technical expertise, right? You cannot just dump everything to these guys, unsung heroes. It's kind of like has to be an ecosystem play for us to really commercialize this technology. Okay, so maybe to Hao Qing, the last question to a panelist before I turn it back to the floor. So, Hao Qing, you've been in Singapore for some years already, right? And you know how Singapore operates. We don't really have a lot of resources, and we are not like great producer of quantum technologies like China, US, and Europe. So, what you presented yesterday together with Jing Yan, is Jing Yan here? Okay, Jing Yan. So, you guys presented a very nice overview and how you put together different QKD technologies, even QRNG systems together across the whole island, right? Essentially playing a system integrator role. So what are your lessons that you have learned that you can share with the students, when you put everything together, right? What works, what doesn't work, and, and what they should be thinking about from a research perspective?
Okay, thanks for the question and comments. So from our experience in the National Quantum Safe Network testbed, I think as yesterday I mentioned, the interoperability is a key part. And this interoperability partially is enabled by the standards, especially on the interface, which is something I think we overcome this challenge and using existing standard and technology to put all the technology work together. And from our experience, another challenge actually maybe for the standard take a role, it's for people to understand the technology, especially for the people outside the community. So standard somehow also help people to know what's the definition, what QKT can do, and what is needed there for the technology to be adopted in today's ICT world. So I think for the QKD to be more practical use, we need to look at the bigger picture, which is today's ICT world, the digital world. So actually, there's already a lot of standard deployment ongoing, like 5G, 6G. All this technology, it's already reached a very high maturity level that put in practical use. So actually, for QKD community, I think there are already many references we can learn from. And take another example is on the very discussed PQC standardization in US. But so far, from my knowledge myself, there's no QKD protocol standard in the market. So from desperate all these years efforts, we don't yet define what's a protocol and what is BB84, what is a CVQKD. There's no such standard well defined. So this is a critical missing part, a gap. So if you talk to the certification body, they will ask for the reference on the protocol implementation, which essentially in the community, we don't have such document. We have many research paper, very good written, but so far since 1984, the born of the QKD, till today, we still don't have a well-established QKD protocol standard, which one of the roadblock to make this technology to more practical or more adaptable or more understandable. I guess some of you may heard about this BSI QKD position paper from a few years. I don't like the conclusion and the first page, but I actually like the description on the problem they say. So for the QKD to be more practical and adaptable and to be eventually to be certified, there are three roadblocks there. Well, first one is a QKD protocol standard. It should be a well-established standard to describe the protocol. Another is understanding of the security proof, which is also, I believe, also a challenging topic in the research community. And the third one is, of course, also we will have the talk in the following session on the implementation and security of QKD. I think if these three questions can be well answered, I think the wider community would have a bigger confidence or better understanding on the technology and be more willing to integrate this technology into their solution. That's my observation and feeling from this year's work.
Yeah, thank you very much for sharing them. I think they're all very useful points. So before we wrap up, we have time for a few questions. Anything from the audience?
Oh, sorry. First, I want to say thank you very much for all the panelists for this interesting discussion. I'm not very well familiar with QKD standardization, but I know a lot about the post-quantum standardization effort. So one thing that I like how cryptography standardization has happened in the last many years is that because this is about security, the resources of the community were utilized in this open standardization process with this round-based systems where proposals have been weeded out by the community. So I was wondering what your thoughts are comparing the QKD standardization efforts to this. Are there also efforts of drawing on the resources of the community in such a way?
Maybe Gillian, do you want to take a stab at that?
Sure. I'll give a practical example. So we have Professor Chang on stage. We have Dr. Chin as well. We have a lot of experts that are coming from the academic and research community that have been instrumental in developing our QKD standard. So I think every standards body is a bit different, but at the ITU, we like to leverage the entire community of stakeholders. So academia is at the forefront right now, leading the work on our QKD related standards, but we also have the input from governments and industry players as well. So I think, yes, but you would have to look different at each standards development organization for the specifics.
Anyone else from the panel would like to add on to that?
Maybe I can say something about the standardization. And for the academic, for some university, okay, not USTC, the standardization is a KPI or can help you to promote, but not USTC. USTC is a kind of research-driven university, but we are still. But if you have a startup, you definitely want to make your product to be used by anyone, then that's why you will be interested in the kind of industry. For example, for our TC, the computation and metrology, You know, the computation shouldn't be very practical, useful in the next 10 years, but still about 20 companies like Tencent or Huawei, they join our TC, they want to work on that. So that's people work for the future, I think. Sometimes work for the future. But for QKD, people work for their company. And also some university work for their KPI. Yeah.
Okay, thank you.
Yeah. Any more questions?
Thanks a lot for that panel discussion. I guess my question relates to the interaction between research and standards. It touched on it at multiple points of the discussion, but I mean, to an extent, it looks to me like there's a bit of a conflict where research, especially in quantum, a lot of it is still at a very early stage, at a very early technical readiness. And I guess things also change. There are new attacks, new protocols that may be better than past protocols. And then standardization, as I understand it, as well, it's supposed to give some certainty, right, that companies can actually adopt this. So I wonder, yeah, how you navigate this tension and kind of how you see the ideal, I guess, like information exchange between like research and standards.
Professor Lee, may I invite you to take on that question?
Based on my 25 years I'm dedicated to a standardization field, actually, when you just find out the kind of very new observations, then we are just considering to find the published that paper. But if that repeatedly we just observe that the same phenomenon or same results, then we have to consider that we can publish the standard method. So probably there is a real difference between the academic paper and the standard document, reproducibility and the reliability. And also, in case of the paper, it's a kind of a new knowledge, but in case of a standard, it's a support some kind of level of industrialization. So that is a kind of the benefit to the all publics. So if we just establish the good standard method, then probably you can accelerate that industrialization. That is a kind of my philosophy. Then after we just use that kind of our new knowledge, then we can pursue the two ways. One thing is a patent. The other one is also standard. It's very different kind of properties. One thing is a height and the other one is open. But the goal is how we can accelerate the industrialization. So please consider that that kind of the difference and the similarity with some paper and standard and also patent and standard. Then anyhow, the purpose of a standard is kind of supported the industry people and also industrialization. So that is kind of the basic nature of a standardization activity. So I just totally agree with that one panelist, Dr. Chin. And probably in the field of QKD, probably important part is interface. Even though we developed the BB88, that also SC and ITU developed some kind of standards on that field. However, that sometimes that method is differed. So probably our role of JTC3 is something like a harmonized that something existing standards or some also support. In case of a QKD, we have to think about some device, QKD distributor. In this case, we have to develop some kind of an interface method. Already the panelists indicated. So this is the kind of our practical role of a standard society. So we are just aiming to that. JTC3 is aims for the achieve that kind of a goal to support the industry. Okay, thank you.
Yeah. Maybe I would like to add some things. It depends on the field. For example, for the QKD, is kind of a mature, so people are doing the standardization. But of course, there will be some new protocol. For example, in the morning, I thought we found that the K rate can increase a lot by using some new protocol. But for that kind of thing, you can revise your standardization, you can upgrade it, but you should do something if you really want to use it. And for quantum computation or for some kind of measurement or something, if it's not mature, there are 2 points. One is in the standardization group, sometimes you are not making new standard. You are doing some technical report to analyze the gap between to analyze the maturity, to tell what you need to do to make a standardization. That's called a technical report. And second one, you definitely need some terminology. For example, for the GTC3, we have the terminology, we have the benchmarking. How could you benchmark a quantum computing? How could you tell it's a good one? And then, well, like the computation volume or whatever, and also the supply chain, such kind of thing. So, of course, I agree that the quantum technology, for some part of quantum technology, is probably too little bit far away from maturity. So in the sense, we need academic and also industry work together. Yeah.
Yeah, maybe let me wrap it up. So I don't think there should be any tension or conflict. It's really just repositioning your thinking, right? As Professor Zhang Qiang was saying, is that, standards, they are living documents. They get updated from time to time, very much like your post-quantum cryptography standards. We update them whenever we need to and remediate whenever we need to. So it's really about coming together as a community to decide on what will be, like, let's say, to Hao Qing's point, that this will be the standard to use for a given protocol. And then the research community can continue to work on, future protocols, right, that will go on to improve the performance with inputs from the industry. So we have to work hand in hand, right? So I don't think there is any tension or conflict. Any more last questions? If not, we will wrap it up already. Nothing? If not, let's give a round of applause to the panelists.